I'm going to do another example of when you're doing integration and you have a variable as an exponent. So let's say we have 10 to the square root of x power over the square root of x dx. And we're doing antiderivative here. So again, we have the issue, we have a variable as an exponent. So we have to do that funky thing where we rewrite. So you're going to rewrite that as e to the natural log of 10 power. And then, like we saw in the last example, when you take that to the square root of x power, you end up just multiplying by the square root of x, which I'm going to go ahead and write as x to the 1/2 power because we're going to have to do it anyway. Okay, so I just kind of did 2 steps in once. Actually, I guess I kind of did 3 steps in once. So you're going to rewrite it using e. You end up multiplying natural log of 10 times the exponent that's already there. And go ahead and change your square roots to x to the 1/2 power. So here's what I have here. Okay, this is a little different than the last example I showed you, and the reason is because you have an extra variable out here. It's not just e to this extra long exponent, you also have a variable out here. So you have to do it a little bit differently. You can't just do the antiderivative the way it is. So when this happens to you, we're going to simplify everything. Let's do u substitution. Let's try to simplify it, take all the chunky stuff out. Okay, so we're going to call this entire exponent u. So u is equal to the natural log of 10 times x to the 1/2 power. And then, as always, when we do u substitution, you then do du, which is the derivative of u. All right, so use your derivative rules. Bring the exponent forward. So I have 1/2 natural log of 10 x to the negative 1/2 power. All right, so that's my derivative. Okay. So in u substitution, your goal is to rewrite everything in your integral as u's instead of x's. So in other words, we got to take all the x's out. All right, so it's easy in the first one because we replaced the whole exponent and called it u. Okay, so that means I have e to the u on top. Now let's think about it. What I have left over here to replace is 1 over x to the 1/2 power. That's what I have left. I have x to the 1/2 power under a fraction bar, and that's the same thing as x to the negative 1/2. All right, well, that's what I have right over here. So all I have to do is get that by itself, and that's going to tell me what I need to substitute over here in my other side. So I'm going to get that by itself, which means, like right now, if I clean up this du, I have du equals natural log of 10 over 2 times x to the negative 1/2 power. So to get x to the negative 1/2 power by itself, I got to flip this little fraction upside down and multiply both sides. So that gives me 2 over natural log of 10. And again, when I multiply the right side, that cancels. So that equals x to the negative 1/2 power. So that's what I have to substitute in there. So instead of 1 over x to the 1/2 power, I have times 2 over the natural log of 10, and then your little du. Okay, that's what I have. This is 10, by the way. It looks kind of messy. And then the other thing I would do, before I do my integration, I like to make things as simple as possible. This thing right here, that's just a coefficient. It's just a number. It's ugly, but it's a number. And whenever you have coefficients, you can take it all the way out, just like we did pi in the last section. So I put that in front, and all I have left is eu times the derivative of u. Now you're just going to do your calculus, okay? When you do the antiderivative, e is its own derivative, so you end up with e to the u. You always divide by the derivative of the exponent, but the derivative of u is just 1. Just like if you had x, the derivative of x is 1, same thing here. So I just get e to the u power, and then I got to bring that 2 over natural log of 10 back. That was out in front. And the last thing you do is we got to put the x's back in. So go back to your substitution where you defined u. So for us, we called u, oh shoot, I forgot. I don't know if it'll let me bring it down. Oh yeah. So u is natural log of 10, natural log of 10 times x to the negative 1/2, was it negative 1/2 power? No, that x to the 1/2 power. Okay, I should probably erase that because that's gross. X to the 1/2 power. That's what u was. So you have to put it back here. So 2 times e to the natural log of 10 x to the 1/2 power over the natural log of 10. You have one more step to clean up. Remember how this all started. You had the number 10. You replaced it with this e expression, so go ahead and put 10 back in there. So you have 2 times 10 to the x to the 1/2 power. So that x to the 1/2 power is an exponent, don't forget, over the natural log of 10. Okay, and that's how you're going to leave your answer. Then don't forget your goofy plus c. That's that one. So the difference between this and my last example, again, if it let me pull it down, the difference is after you substituted for that e, you had an extra variable right there that caused problems. So you couldn't just do the antiderivative and be done with it. You had to go over here and do e substitution. So whenever you have an extra variable in there, think u substitution. Okay, that's it.